Okay, so this is going to be the first of a couple videos of piecewise functions, okay? So in this particular video, we're going to take a brief look of how to graph piecewise functions, okay? And all a piecewise function is it's a function that's made up of other functions, okay? So this is an example right here. So as you can see, we have this function f of x, and it's equal to, and it's made up of two individual linear equations here, okay? Now we have one equation here, negative x plus 3, if x is less than or equal to negative 2, and we have 2x minus 4 if x is greater than negative 2. These are the two rules, okay? So when we have piecewise functions, there's a few different pieces in here, okay? The first part that you're seeing here is the function rules. What we're seeing here in these two colors are what we call the function rules. And that's going to be what you graph, okay? Each of these is what we graph, okay? So these are going to be what we graph. Okay, and then what you see over here with the if and if, these are what we call the domain restrictions, okay? This is what we call the domain restrictions, okay? Domain restrictions. Well, the function rules are what we graph. The domain restrictions are when we graph it. Okay, so a piecewise function is made up of function rules and domain restrictions. You'll also hear me refer to these function rules as subfunctions from time to time, okay? Just some vocabulary here. So these I also refer to as the subfunctions. And the number of subfunctions we have is how many pieces on the graph we are going to have, okay? So if we look at this particular piecewise here, we have two separate function rules, which means we're going to have two pieces of this graph, hence piecewise functions, okay? It's going to be different pieces of the function. Okay, so I'm going to graph this. And what this is saying here, what this part up here is saying is, this is saying, hey, we want to graph y equals negative x plus 3 when x is less than or equal to negative 2, okay? So there's a few different ways we can do this. One way is by creating a table. So I'm going to go ahead and do that down here. So we can create a little table, okay, for y equals negative x plus 3. Okay, now we're only going to graph this when x is less than or equal to negative 2. So I can plug in negative 2. I can plug in negative 3, I can plug in negative 4, and so on and so on and so on. Because all of these values are less than or equal to negative 2. So that's what I'm going to go ahead and do. I'm going to go ahead and plug each of these in for x and simplify for y. I'm going to solve for y. So it's going to be y equals, I'm going to plug in negative 2. Be careful with your double negative. I'm going to have negative 2. That's going to become a positive 2 plus 3, which gets me 5. So I'm going to have negative 2, 5. I can plug in negative 3, so negative x. So notice I'm just plugging into the rule here, negative x plus 3. Well, that's going to become 3 plus 3. This gets me y equals 6, and then if we plug in negative 4, y is going to get a 7. So we can go ahead and plot these points. So we have negative 4, 7, negative 4, 7. We have negative 3, 6. And we have negative 2, 5. I want to take a step back for a second here. These rules here, or these domain restrictions here, these domain restrictions that tell us when to graph it, these also tell us where we start and stop, okay? So This is telling us we're going to graph negative x plus 3 if x is less than or equal to negative 2. So we have to stop when x is negative 2, okay? So I have negative 2 here. Now, since it is or equal to negative 2, we can actually be negative 2 for x here, okay? I can actually be negative 2 for x here. So I'm going to show that with just another dot, okay? A nice closed circle, just like an extra point, okay? And I mean, you can probably figure out the pattern here. The slope is negative 1, so I can go up 1, left 1 to continue the pattern. And this will be the first part of my graph, okay? So as you can see, that is a graph, negative x plus 3. I could continue, and I would hit the y-intercept, but it's only when we're graphing this particular function when x is less than or equal to negative 2, okay? Because it's telling us to stop at negative 2. Now, we have another part, though. We have 2x minus 4 when x is greater than negative 2. So we have y is equal to 2x minus 4 when x is greater than negative 2. So I have to go ahead and make an xy table, okay? We got to think about some numbers that are greater than negative 2 for x, well, like negative 1, and 0, and 1, and so on and so on, okay? So I can go ahead and plot these numbers. So I can go ahead and plug this in. I'm going to go ahead and plug in negative 1. So I'd get 2 times x, which is negative 1 minus 4. It's going to become negative 2 minus 4, which is going to get me negative 6. So I have negative 1, negative 6. I can plug in 0. That's going to be y equals 2 times 0 minus 4. That's going to be 0 minus 4, which is just negative 4. So I have 0, negative 4. And if I plug in 1, that's going to get me negative 2, okay? Now, this is when x is greater than negative 2. So the common mistake is actually to start at negative 1. But there's something incorrect about this. What about all the numbers in between negative 2 and negative 1? There's actually an infinite number of numbers in between negative 2 and negative 1. So this here was telling me I need to stop the pink graph at negative 2, but this is telling me I need to start the blue graph when x is negative 2. Okay, so I actually have to plug in negative 2. If I plug in negative 2, you would end up getting negative 8. And I know some of us might be saying, well, this is saying when x is greater than negative 2, why am I plugging in negative 2? Well, that's because we need to know where this graph starts. And I know x cannot be negative 2 in this case, so I show that on the graph with an open circle. What this open circle is saying is, hey, the graph doesn't exist right here, but it starts immediately after it, okay? So x, you can't be like negative 2, but you can be like negative 1.99 or negative 1.9999 or something along those lines. So that's what that open circle represents. So then, now that we have that, we can go ahead and we can get some more points if we want to. But this will be a rough sketch of our graph, okay? And this would be the graph of this particular piecewise function, okay? So notice that there was 2 function rules, there was 2 sub-functions. I have 2 pieces to the graph. Notice this graph wanted me to stop when x was negative 2, so I went from negative infinity all the way up to negative 2, and that's where I stopped with this particular graph. And this one here is telling me, hey, you want to start when x is negative 2 and then go on forever, okay? And notice when it was or equal to, I stopped with a closed circle. When it was not or equal to, we started with an open circle, okay? So that is kind of an introduction to graphing piecewise functions. I'll make a couple more videos, probably some more complicated examples, okay? But this is an introduction to graphing piecewise functions. Make sure you check out the next video so you can get kind of a full of understanding of what these graphs are going to look like.